Is that?
It's good. All the way to the top, please.
Maybe, yeah, start at the beginning.
So these were the two designs we were looking at.
Okay. Chauncey, we haven't done our sections yet. You got to go to the beginning.
Oh, okay. That makes a whole lot more sense. I thought I really missed something there.
All right. We're the daylighting team. Can you skip the next slide, Chauncey? And that one too. Okay, so there are a couple of inherent issues with CPC design, issues that we in the past design and have now addressed. The two primary ones come from the two equations for CPC. Equation one here being the concentration ratio versus the input angles, and the second one denoting the height versus input angles. The takeaway from this is that as you get wider and wider input angles for a CPC, the height goes down and the concentration factor also goes down. Yes. Yes. Yeah. So, however, these are at odds with one another, as we want the highest possible concentration factor, the highest possible input angle ranges, and the lowest possible height, each one of which is at odds with every other measurement. So if you could go to the next slide, Chauncey. The first iteration of our design was taking these CPCs, putting them, extruding them north-south so that they are arrayed east to west, so that when the sun goes over them, they go through the gambit of input angles. So if you wanted, say, if you had a 90-degree input aperture or 90-degree angles of input, then you would have, that'd be 6 hours of daylight. And then the moment the sun gets out of that area, it just immediately shuts off. However, we have updated this design. If you could go to the next slide, Chauncey. Quite literally by just rotating it 90 degrees. Makes it far better. This design will accept the sunlight from any angle, however it varies with the cosine of said angle, as we are, well, I suppose that'll come later. Because we are extruding it east to west and arraying them north to south, we only have to care about the axial tilt of the Earth and the way the sun goes through the sky and the 47-degree range of angles that we have to deal with for those possible positions of the sun. So we can create a much stronger CPC with much lower input angles that is, well, taller and has a much higher concentration factor. Can you go to the next slide? Lovely. So this is comparing the two designs, the one that goes east to west and the one that goes north-south. This graph denotes the amount of light that would be input into each one over the day. For the east to west design, that you can see that it provides constant light and then drops off the moment the sun gets out of its acceptance angle. For the other design, though, it varies with the cosine of the angle of the sun, and so long as the sun is within this 47-degree arc, which it always is, we will have full input into the CPC. You can see that the latter design has a much greater area under the curve, and in fact loses very little even during the daylight hours, where the original design is better. Can you go to the next slide? Okay, there's another concern, which is that if you take this extruded CPC, and this is a diagram of the input aperture and the fact that it decreases with the cosine over time, or as the sun rises and sets. It can create shadows in the CPC if we don't include mirrors segmenting them into discrete segments. It can create large swaths of area where there is no light entering and entire rooms go unlit. So you can get around this by including a series of mirrors inside of this extruded CPC that reflect the light back and forth, allowing for more even light distribution. Can you go to the next slide? Okay, second issue is height, the other equation that we have to deal with. This one is also rather easy to deal with in that we don't actually care about the height. You can just duplicate a CPC, or in 3 dimensions, duplicate it 4 times, and it makes it half the height. So this can be done ad nauseum to as small as you please. So you can just duplicate it smaller and smaller and get this height very low, and thus the volume of the entire system rather low. The only downside to this being the manufacturing costs. You need to create more and more detailed CPCs. The manufacturing costs of this will be explained more in depth later. Can you go to the next slide? Lovely. So for our final iteration of this design, one that we believe would be best, we will not actually create a CPC that has the full 47-degree acceptance angle to account for the entire changing of the sun's position over the seasons. Instead, we can further optimize the CPC's design by reducing this angle to about 8 degrees. And because the sun starts all the way in one direction, moves to the other, and then over again, it moves through about 90 degrees per year. So with an 8-degree acceptance angle, you would only have to reposition it to retract the sun about once a month, which is a very good cost benefit, as it were. And with such a small acceptance angle, first, note the CPC is very, very long. If we weren't using this constant bisection method, it would be very difficult to manufacture these en masse. But the fact that we have such a small acceptance angle allows for a 7.2-fold concentration factor, meaning a single square meter of CPC can be condensed into 1/7 of a square meter of light channeling throughout a building. Can you go to the next slide? Okay, this is some just basic, this is what it might look like in an array. You can see that there are a series of squares that are bisected with mirrors to account for the aforementioned shadow problem. And it would be much larger. These are rather minute, only about 5 millimeter squares. So, and 20 millimeters tall. So about an inch tall, 1/5 of an inch wide. Very, very small, and can be created en masse via injection molding. Can you go to the next slide? Okay, so actually, I'm not sure this is the right one.
Skip it?
What's that?
You want me to skip again?
Don't worry about it. So these are some basic mock-ups of the design and manufacture cost. If we do injection molding for the manufacturing method, which seems the cheapest, you can produce about a square meter of this for $80 worth of material. In terms of injection molding, it's reasonable to, I requested a quote from a company and found it reasonable to assume a 2-fold, the production cost is about twice that of the material cost, meaning we multiply the overall cost by 3 to obtain the full cost of the CPC array. However, with injection molding, a significant amount of the cost is upfront with creating the tooling that can later create the CPCs. This can be amortized over time, seeing as we will create hundreds of thousands of these. In one of the previous slides, it was mentioned even a square meter has 20,000 CPCs in it due to the very small size. Good tooling's costs can handle this volume quite easily, but cost on the order of $6,000 for even a decent one, more for better ones. I'd budget at least $20,000 for it, but if volume were high enough and they were used over time, this becomes quite nearly negligible in face of the larger cost of the materials to manufacture. Can you go to the next slide? Okay, this is Chancey's.
Okay. Can you all hear me well enough?
Yes. Go ahead.
And I presume see me now? That, so these are the two designs for the light capturing. So the CPCs would go on top of these slots you see right here, enabling us to capture all the light that would that these arrays would encounter in their general cross section. So we don't have any gaps in between what we're able to capture. But trying to minimize space, we were at first planning on the one you see on the right, where it tapers down to about half the width. But running some calculations, while there are some benefits to that, the downsides are much greater, and we end up losing the amount of light captured pretty much close to the ratio of the decrease in the radius or the distance. So if we decrease to 1/2 of the initial entrance, then we only capture about 1/2 of the original light. So that's why, though it takes up a larger space, we switch to the design on the left where the light slots are not tapered and instead flow down. This makes for greater interstitial spaces, but that can be accounted for with CPCs, which is why they're integral to the design. And as you can see, and as we've talked about before, that the light goes through the CPCs, which I excluded to be able to make this portion look more clear, and then is reflected down into the bottom to the common light channel. And these can be stacked next to each other so that it truly is a common channel going all the way to the end of that array, where it effectively dead ends into light guides, which we'll be using fiber optic light guides as they're the most common and the cheapest. So these are the advantages and disadvantages. That the ones that aren't tapered and stays the constant distance on the way down require a little bit bigger CPCs, which increases cost, but the cost is worth it as you're able to maintain more of the original luminance. And then the reverse below. The tapered ones have a smaller footprint, as you can see, but again, for the amount of light that's able to be captured with the non-tapered one with a larger footprint, it's still beneficial to use that one. And oh, okay. I thought I had more.
Yeah, you have more. Yeah, this is the graph we can see as it's actually the graph with normal incidence with respect to the angle of its normalized intensity with respect to the angle of incidence. You can see like for the power source 1 watt each. I have used 2 power source, like for at 0 incident both are collinear, and like for 30 degree I have placed one at +30 and one as -30. Similarly, we have modeled the simulation in that way, like for 2 watt power into the CPC, we use the power monitor to see like how much energy we can capture. It's approximately 65%, as you can see. And as the angle increases, we can see that there is a drastic change in the amount of light energy received by the power monitor. And eventually after 35, it's almost become null. The next one.
We have 1 minute left.
Yeah.
So
Oh, this is the model. Like this is the at the incidence of 0 degree. Like we can see like there is a monitor shown in green, like it calculates the amount of power received at that point. And below the monitor, there are two small pink dots, like this is basically here. And from those two pink dots, it's the optic fiber that is carrying the light. It's not simulated up to infinity, but it's for simulation, we have to define a model. So that's the end of the model. So we can see that basically for 0-degree angle of incidence, it's approximately 63% of power we are receiving. The next one. Sansi. Yeah, this is the model I modeled in COMSOL. Like I wanted to see the difference in the amount of power received in both. So here similarly for the tapered region just outside the CPC, it's glass. Basically the glass and the optic fiber had almost similar 1.5 refractive index. So predefined was their glass. So the amount of light received by the monitor almost remains the same. The next one. Yes, Sunset?
I will try to wrap up soon.
Yeah, it's
We can go
Sunset.
to the, no, this is mine, but
Okay.
we can skip it.
So I have a suggestion for you. We
Please.
have a lot of material. Can you record a video with the remaining slides and submit it to me, and then I can actually at least try to understand it.
Okay.
If you go too fast, I won't understand it.
Okay.
Sorry for going over.
It's fine.
Okay.
I just want to be fair and make sure everyone else.
Okay.
So,
So did you hear me, Chauncey? Just record the video with the slides and send it to me. You can send it to me separately or together. Either way is fine.
he
At
jumped
least so I can understand it, okay?
Okay.
Okay, yeah.
Go to the conclusion. We can stop there.
Can you jump to the conclusions, Chauncey?
Oh,
Yeah.
okay.
Okay, so this new CPC design, far more efficient than the old CPC design. And while it does require some amount of maintenance in the form of rotating this about once monthly, it's not that bad, shouldn't take more than a couple minutes once a month. So there's also, it is of note that these CPCs are quite a fair bit more expensive than solar panels by a factor of about 4, but require very, very little maintenance and have incredible lifespans as being purely mechanical.
Okay. Sounds good. Well, thank you. We should stop here. Sorry. We're just, okay. Let's